Welcome to this explainer. Okay, today we are tackling a massive real-world problem for us budget-conscious developers. How exactly do we unlock and run the incredibly powerful Claude Code on Windows completely for free without needing premium subscriptions or dropping thousands on a high-end GPU? I mean, if you've ever looked at the pricing tiers for top-tier AI coding assistants, you know they're almost always locked behind standard or max-tier paywalls. It's frustrating, right? But today, we're going to bypass those barriers entirely. We're going to walk through a remarkably clever workaround that lets you harness unlimited AI coding potential right on your local machine.
Here is our roadmap for today. First, free AI coding unlocked. Then, installing your core tools, followed by bypassing hardware limits, connecting the cloud model, and finally, building your first game.
Free AI coding unlocked. Let's break that hardware barrier.
So to start us off, we really have to acknowledge the barrier to entry here. Natively, Claude Code just isn't free, and running massive AI models requires some heavy-duty computer resources. If you want to run cutting-edge AI agents locally on your own machine, you typically need a massive graphics card and a ton of memory. Now, while local models are perfectly fine for super simple tasks, like auto-completing a single line of code, they just cannot handle the heavy lifting. But by leveraging a cloud model, we bypass the heavy hardware limits of our local Windows machines entirely. This is absolutely necessary for complex tasks, like generating an entire web app from scratch, mainly because cloud models don't tax your local GPU at all. Your computer essentially acts as a remote control. As long as you have a solid internet connection, you can orchestrate incredibly complex coding tasks without your computer even breaking a sweat.
Moving on to Section 2, installing your core tools. Let's get into the setup phase. Let's establish our foundation by installing two simple but absolutely essential tools via the command line. These are basically the engines that will make this entire process possible. And hey, don't be intimidated by the command line. It's literally just a text-based way to talk to your computer. First up, you'll head over to Ollama.com. You can download it directly from there, but using PowerShell is highly efficient. You just paste the command and let it download. Then, you verify it by opening your command prompt, or CMD, and typing Ollama-H. Now, a quick troubleshooting tip for you here. If CMD throws you an Ollama command not found error code, don't panic. Simply close the window, restart your computer, and try it again. It usually clears right up. Once Ollama is ready to go, head over to the Claude docs, grab the quick start command for CMD, paste it in, and hit enter. After that, just type Claude to ensure everything is running perfectly.
Okay, once everything is installed, it is crucial to set up a dedicated workspace. By opening this PC, navigating to your D drive, and creating a new Cloud Projects folder, you're establishing a very clear sandbox. You then open CMD directly from the top bar of this specific folder. Why do this? Well, it tells the AI exactly where it's allowed to operate and save files securely. You absolutely do not want an AI agent having free reign over your entire hard drive. So this step keeps everything organized and contained. For beginners especially, this is incredibly important best practice. Keeping the AI contained in this specific folder prevents it from accidentally modifying or deleting any of your vital personal system files.
All right, Section 3, bypassing hardware limits. Let's find the right model for the job. With our tools firmly in place, we're going to navigate the Ollama library to find a model powerful enough to code, yet light enough for our computer to actually handle. Now, while you could browse Ollama's online library to find various open-source models like Qwen 2.6 or Gemma 4, we need something specifically tailored for heavy developer usage without melting our local CPUs. So we are specifically hunting for the GPT-OSS cloud model. This is an incredible AI packed with a staggering 120 billion parameters, specifically designed for powerful reasoning. To put that massive number into perspective, the much smaller 20 billion parameter version of this model takes up about 14 gigabytes of space on your hard drive. So just imagine the astronomical file size and hardware requirements of the 120 billion parameter version if you tried to run it locally. There's literally no way a standard PC could handle it, which is exactly why this specific cloud-based model is our go-to choice today. Here is the absolute most crucial point of the setup. When we use the pull command in CMD for this 120 billion parameter model, just typing Ollama pull and the model name, we are only downloading a lightweight manifest file to our system. It's going to say success on your screen, but you haven't actually downloaded hundreds of gigabytes of data. You've just downloaded the instructions that point to the full model sitting up in the cloud, leaving all that heavy computation strictly on the internet. It really is a remarkably clever workaround.
Section 4, connecting the cloud model. Let's bring all of this together. Now that we have our manifest file successfully pulled, it's time to connect our local Claude Code interface directly to that massive cloud-based brain. This is exactly where our local sandbox meets unlimited cloud computing. By simply typing the launch Claude command in our trusted folder and using the arrow keys to scroll right past the standard local models to select our newly linked GPT-OSS 120 billion cloud model, we instantly bridge the gap. You are effectively wiring your local command prompt up to a world-class AI supercomputer with just a few keystrokes. Oh, and if you happen to experience a timeout or the model hangs while trying to connect, it's almost always a simple connectivity issue. Just double-check your internet connection or temporarily adjust your Windows firewall settings, and then try the launch command one more time.
Right during this initial connection, the system is going to pause and ask for permission. It will literally prompt you right there on the screen, asking if it's okay to run in this directory. Confirming yes, I trust this folder is a vital best practice to ensure the AI only has access to your designated project sandbox. This is the exact moment you officially grant the AI its working credentials for your D drive.
And finally, Section 5, Building Your First Game. Time for the final proof.
So all the setup is completely done. Let's put this newly unlocked power to the test to see if it can build us a working project from scratch entirely for free. We feed Claude Code this exact simple prompt, instructing it to generate a fully styled functional web game without us typing a single line of actual code. Notice the typo in there? We wrote tic-tac-toe without the E at the end. But guess what? You don't even need to fix it. That 120 billion parameter reasoning engine is more than smart enough to infer your intent. We aren't giving it rigid step-by-step programming logic, we're just giving it a natural language command. The interface will pop up and ask, do you want to proceed? You just hit yes, and it starts thinking.
After just a brief moment of thinking, we can look inside our trusted Claude Projects folder and visually verify these 3 specific files generated perfectly by the AI. It dynamically creates a tech folder and populates it with an index.html file for the core structure, a start.css file for that beautiful design we specifically asked for, and the JavaScript file to handle the game's actual mechanics. But does it actually work? Well, opening that HTML file proves our setup was a total success. Right there in the browser, you get a fully playable tic-tac-toe game. You can click around to place your X's and O's. When someone wins, the game over state triggers flawlessly and the reset button instantly clears the board for another round. It actually works, seamlessly bridging a free cloud model to a locally functioning application on your desktop. You did it. You've just bypassed hardware limits to unlock top-tier developer tools directly on your Windows machine, all without spending a single dime or burning out your graphics card. You've seen exactly how simple it is to set up a secure folder, pull a manifest file, and let a massive cloud intelligence build real, working software for you. So, I leave you with this final thought. With all this new, unlimited power at your fingertips, what ambitious project are you going to spin up next?